Hi, welcome back to day two. We are on page 6. We are talking a little bit more about scale factors and how we can use those scale factors to solve for a missing side if we know that the triangles are similar. And that's a really big point that I have to point out. We need to know to solve for a missing side that the triangles are similar or the polygons are similar. If we don't know that they're similar, we cannot use this process. So that's a very important thing. We can use those scale factors, or if you want to call them similarity ratios, to solve for missing sides by setting up a proportion, just like we did on day one. And then, as I call it, cross multiplying. And remember, I said on day one, you might have something else that you call it, and that is okay. Okay. So if you look at these two triangles, one is big, one is small, and I can tell you that these triangles are similar. So you have a teacher telling you the triangles are similar, and it looks to me like they are oriented the same way. So it looks like if you look at this one over here on the right, this small triangle looks like it has a small side, a 3, a medium side, a 4, and a big side, a large side, which is a 5. So what's going to happen here is we're going to have a small side right here that matches up with this small side. We're going to have a medium side here that matches up with this medium side here. So the 12 and the 4 are going to be similar partners. And then the X is going to be the large side, just like the 5 is the large side. So I could come back in here with my small and my medium and my large and my small and my medium and my large. And the first thing I need to not do is minimize my screen. There we go. The next thing I need to do is determine how I want to set up my ratios. So do I want to go from left to right, which would be the big triangle to the small triangle? And I'm going to tell you that's always my choice. If I can go left to right, I go left to right. That way, I don't have to think about it every time. It's just a little bit more automatic. So I'm going to write all of the ratios. I'm going to do the ratio for the small, which is going to be 9. Here's your small to 3. I'm going to write down the medium, which is 12 to 4. And then here's my large, my X to 5. And I'm going to use this information to help me solve for X. Solving for X is the same thing as finding a missing side because this X is a missing side. Okay? Now, when we write a proportion, if you remember back on day one, we only needed 2 ratios. And if you look at our particular situation here, well, we have 3. That's kind of interesting. So if you look at the 9 divided by 3 or 9 to 3, and you look at the 12 to 4, and you pull up Desmos, let me get rid of this previous problem I was doing. 9 to 3 and 12 to 4. You see that the ratio is 3. Can you all see that 3 there? So what that tells me is that I really don't need to worry about which one of these I use. I can use either one of them because they both simplify to 3 which is really 3 to 1. I hope that makes sense, because this is really 3 and this is really 3. But when you have a whole number, the denominator is 1. We just don't write 3 to 1 normally. But when we need to use a ratio, it's kind of important that we have that denominator. So that's why we're doing that. So that's going to take care of one of our two ratios. And because we have to solve for x, this is going to have to be our other ratio. Otherwise, how would we solve for x? So remember, when we cross multiply, we multiply on the diagonal. So we'll have x times 1 equals 3 times 5. Most of you are going to be able to do this in your head. If you need to, you go over to Desmos. But for now, x times 1 is just x. 3 times 5 is 15. And that's going to be the missing side. And we can check that. We can say, hey, what if we now put this 15 back in here? Would that 15 divided by 5 still be 3 to 1? Let's try it out. 15 divided by 5 is still 3. So what that does is it helps us solve for the missing side, but it keeps that scale factor the same between all three ratios. And when we come back together in the class, we're going to be doing some of these together, but you can tell down here at the bottom, they get just a little strange looking. So, and on the next page, on page 7, they do get slightly, oh, and here's a circle. They get slightly strange looking. So we're going to do those as a group. Thank you for listening. Take care.